let's go further and try to discuss the research approach. Normally we talk about two kinds of approaches, deductive and the inductive approach. Now, very simply try to understand what is a deductive and what is an inductive approach. See, we talk about a deductive approach. Whatever we were doing today in our last session is, that we say that we hypothesize that there is a relationship. We say there is a theory or something, we say a fact or something, we say that there is a relationship between this and this. You go, collect some data, test it, and prove or disprove it. That's what you're doing. You're trying to deduce something from the statement that you made, from the hypothesis that you made, from something what you assumed, right? So you deduce something. So what it says is, ideally, for a quantitative research, the best approach will be a deductive approach. To try to deduce, isn't it? That's what we do. As far as inductive approach is concerned, you say that you do not know something about a particular phenomena. You cannot assume. What you do is, you say, okay, let me go and talk to people, or let me observe. Sometimes you go and observe, or you say, okay, let me have a focus group, let me call some experts and discuss this, and see what are their different opinions. You collect all the opinions or all your observations. Based upon that, you say, okay, they are talking about that, there's a particular phenomena that happens. And then you finally end up with a theory. So what you're trying to do in an inductive approach is, you're trying to induct a theory based upon your observation, or based upon a focus group interview, or on the feelings or the opinion of people. You say, okay, now you develop a theory. So inductive approach is more suitable for a qualitative research. It's more suitable. You do not test a hypothesis there. You go and talk to people, or maybe you observe. So these are two approaches. So remember, a quantitative approach normally will have a deductive, and a qualitative normally would have an inductive approach. Though it's not a scientific rule, but you can say as a rule of thumb or something, generally acceptable practice, you can say, an easy way of doing things. So a quantitative or qualitative, so if you are following a quantitative, it will be a deductive approach. Qualitative, it will be an inductive approach. Remember, a quantitative starts with a theory or an idea or a relationship, and we go on to collect data to prove the same. That's what we do in a quantitative research. So we say a theory or an idea. Idea is that there is a relationship between two variables. That's our idea. Then we go on to collect data to prove the same. That whatever we proposed, is it true or not? So that's what we do in a quantitative. Qualitative, you have or you collect some data like opinion and beliefs, which ultimately leads to a theory development. So you develop a theory at the end. Okay. Now let's see. Now a very important point.
I'm sorry.
Yeah.
Now in terms of developing a theory, is that part of the recommendations, or is that your secondary research, or a secondary process out of the primary research?
No, see, in a qualitative, the development of theory is the final outcome.
Okay.
This is the final outcome of the research, that finally you develop a theory that, okay, this is what really happens, or these are the relationship between different things.
Okay.
So that's the outcome of the research.
Your conclusion.
Yeah, the conclusion.
Okay.
The theory is in fact the conclusion of the research.
Okay.
That's what happens in a qualitative. That's why I tell you qualitative is more difficult. Sometimes it's a longitudinal study. You study that over a period of time. You cannot do it at a point of time. So that's why it's more of a longitudinal study. Maybe you do it over a period of 2-3 years altogether. You study and then develop a theory. So it may take you a long time. The quantitative research is at a point of time. Okay. Now, there is something which is called as a research design. ideally speaking, a research design will include a sampling design, and in a sampling design, the first thing you need to talk about is the target population. Now, what is your target population? You need to define. So, whatever your research is, I hope you know what is your target. What do you mean by target population? Whatever you are targeting, you should very, very clearly define it so that you don't remain confused. You know, where are you going to collect your data from? That's your target population. So, at the time of, before you really start collecting the data, the first thing that should come to your mind is, where am I going to collect my data, and do I have an access to that data or not? Sometimes, you know, you have very optimist sort of a population or something, you know, a particular department that I go and collect data, but nobody gives you an access to that data. If it's your own organization, maybe you have an access. Sometimes it becomes very difficult. I've seen some people struggling because they do not have an access to data. Then they say, what are we going to do? I say, now you can do just nothing. Change your topic, choose another organization, change your research population. If you are not able to collect information from your research population, you have to change your research population. That's what you can do. That's why before you start collecting, or in fact initially you should think about, do you really have an access to your research population? So please try and confirm that. Do you have the access to the data or not? If you don't have data, you cannot research. So first of all, think about where are you going to collect your data from. So it's the first thing is an access, and second thing is the availability of the time. Please also remember, we have to be very smart in thinking. You know, it cannot be, because it's not like a dissertation is a 5-year project. It is not. Yeah, it's not those 5-year projects that we have. So you say that, okay, do you have that much of time? We see a very optimist target. Your target population is spread across the entire country. Now, where will you find time to collect data from the entire country? Even if it's a sample, it has to be a representative sample. So you have to go to almost every province and collect the data. Do you have that much of time with you? So, you know, please be smart. Think. That's why initially define your target population. Only the population should be somewhere where you can go and research, where you can have an access, you have the time. So define clearly. It's no problem. You only say that, okay, my target population is only particular 5 companies, 2 companies, 1 company, 1 province, 1 city, only Centon. You know, define your population very clearly, whatever it is. And second, so definitely you should think about your target population. Yes, sir.
Sorry, to get the letter from the university as to who we're going to send out to request access to something at a company, we should have contact for that letter.
Yes. I think there's another point of something ethics also comes in, that you should have that written permission also. Because normally if you're trying to use the name of some company in your research, you know, you should get the permission from that, because the companies may feel offended when you research without their knowledge, that you're using their data. Sometimes, you know, you may have an access indirectly from somewhere. You know somebody in the company, you get your data, and then but you cannot use the name of the company. So it is unethical to do that.
Yeah, so who do I contact at Regenesys to get the academic letter to send out to the company that we should do the research data from? Who should I contact here at Regenesys?
No, you can. You can get a letter that, you know, you are doing your research from here and that's why you need the data collection. You can get that letter. Yeah, you can get that letter. That, you know, you want to, when you are trying to collect your data, you can get a letter from us that, you know, you are doing a research for academic purposes only.
I think he wants to know who. I got mine from Tawera. So you can contact Tawera.
Yeah, Tawera is the research administrator. So you can write to Tawera, or so that's not a difficult thing, and so you can So that's ethical also to do. So target population. Second thing is the sampling frame. Now when you talk about sampling frame, sampling frame is the list of all the respondents. In some cases, you may be able to find the list of all the respondents in the population. Say for example, you are doing a study of a particular organization. You can go to the HR and have the list of all the employees. That becomes your sampling frame. You are trying to study something about university students. You can get a list of all the students. That is your sampling frame. Why do we require a sampling frame? If you are using a probability sampling, you should have a sampling frame. Otherwise, your sampling is not probability sampling. It is non-probability. Because the very definition of probability sampling is that every respondent should have an equal chance of being included in the sample. So where will every respondent have an equal chance? When you have an entire list and then you say I will randomly pick somebody from this list. That becomes a probability sampling, isn't it?
Yeah.
Say you have got the list of 100 people and then you say okay, randomly I'll pick 1, 2, 3, 4. That's what you do. That's the probability sampling. If you do not have a sampling frame, you cannot use a probability sampling. So please be sure what you are writing in your dissertation, that whether you are using a probability sampling or a non-probability. If you are using a probability sampling, you need to have a sampling frame. For most of the marketing researches, you don't have a sampling frame because it's the general population you are going to. You cannot have a list. You say for example, everybody, you can say all teenagers. Where will you get a list of all teenagers in Johannesburg? This is sort of, you cannot have a list. It means you cannot have a probability sampling. You will have a non-probability sampling in that case. So what you write, please remember, the moment you say you are using a probability sampling, it should have a sampling frame. Otherwise you cannot use. So that's a huge importance and significance of sampling frame.
Now, what does the probability sampling mean within the sampling frame?
See, no, sampling frame is just the list of all the respondents. That's it.
And the probability, what does it mean within that frame?
No. The condition for a probability sampling is that you should have a sampling frame. Then only you can do a probability sampling.
Okay.
That's a precondition of a probability sampling. That you should have a sampling. It means you should have a list of everybody in the population. Then only you can do a probability sampling. Are you getting me? When we say that you are using a probability sampling method, it means you have the list of all the respondents or all the members of the population. You already have the list. Most of the times I tell you, you won't have the list. It's only when you are using a particular organization, institute or something that you can have a list. Otherwise, you won't have the list. It means you are doing a non-probability sampling. Please remember that. And there's nothing wrong in using a non-probability. It's not that it's wrong or right. It depends upon what kind of research you have. Depends upon your research population. If research population is the general public, you cannot have a list. That's not possible. Okay? Then sample size. Next thing is, what should be the size of the sample? That's a normal question. There are many methods, but the easy way out is the software available these days. There is a software called, there are many softwares for online thing. You can have a software called a RowSoft. There is a online available. I'll just show you that. See, this is the software. I don't know whether it's visible or not. Here it talks about what margin of error can you accept. They say 5%. Maybe I just switch off the lights. Maybe you're able to see. It's very small. I don't know. It's not visible. But we go to the software here, which is talking about what margin of error can you accept. it says a 5%, so it's 5% written here, 5. Second is, what confidence level do you need? So you can choose 90, 95%, and then what is the sample size? What is the population? And what is the population? If you have the sampling frame, you say, okay, my population is this much. So it will give you a sample size. Only you input your data, it will give you the sample size. You have to do just nothing. It's a very simple software, and once you find your sample size, you can give a reference that you have found your sample size through using this particular RAWSoft calculator. So now life becomes easy, you don't have to think anything else. I always believe that if there is a technology or something available, we should use it. Why to struggle using formulas? Yeah.
And all it says, you just give, for example, 1,000 and it gives you 275, you can just give it to 275 people as long as they are part of the population.
Come again. Yeah.
I'm saying, let's say you have 1,000 and you punch the 1,000 there, it gives you 275.
Yes.
And then it says your margin of error is 5%, your average confidence is 95.
Yes.
So you can administer it to any of the, anyone within the...
Yeah, within the population. Now, so now that's another thing. Now, how do you choose? Now you know that there is a number called 200. Now, which 200? Now, you know that's where. Okay, we'll discuss that now.
Because if for example you want to issue
Yes.
200,
Yes.
somebody else might say, let me go for the 200 that is closest to me, which is on a convenience basis.
Yeah. So now different bases now. So how do you pick this? Now you have decided that through this calculator it comes to 200, for example. So which 200 are you going to pick? Now if you have the sampling frame or if you have the list, then we say a simple random sampling is a very common method being used. Simple random sampling. It means randomly you choose. So it's like sort of a lottery sort of a system also. There is a list of 100 people. You say, okay, let me randomly pick 1, 2, 3, 4, 5. So whatever your sample size is, you pick randomly out of that list. So and that's a simple random sampling. Sometimes it can be a stratified random sampling. Stratified is like you divide it into strata. Say for university, you say, okay, undergrads, I'll choose 50 from undergrads. So you take a list of that, choose 50 randomly from undergrad list, then from postgrad another 50. That becomes a stratified random sampling. So these are all probable, but this is only usable when you have a sampling frame. That's where you can use simple random or stratified random, because these all are different types of probability sampling. And remember, we said that you can only use probability sampling if you have the sampling frame. If you do not have it, we are already talking about this. If you don't have it, then you use a non-probability sampling. And the most basic non-probability sampling is the convenience sampling. It is out of your convenience that you choose sample. Or it can be your judgment sampling. You feel that this sample should be included in my research, so you include that. So it can be convenience based, judgment based, all those kind of things. But more important is to remember that are you going to use probability or the non-probability one? And the criteria is, do you have a list of the entire population with you or not? That becomes your criteria, and then you decide whether it is going to be probability or non-probability. Is it clear now? I hope that makes sense.
But Doctor, can you note out, for example, you have chosen that it's 200.
Yes.
And then you go through the stratified approach, and then within those groupings, and you say to come up with the 50, for every 5 person, I'm going to elect them.
Yeah, that you can use that.
You can do that.
Yeah, every 5th person.
Yeah.
Yeah. See, the more the confidence level, if if you want a more confidence level, the sample size would increase. You know, a bigger sample size will have a more confidence level. That's the basic logic. The moment you change it, you'll see the difference in the sample size. If you want to be more confident, the sample size should be bigger. That's I think that's on the logic on which it is based. So there are. It's again, see, the same logic applies there also. If you want a smaller margin of error, again the sample size would increase. So that's the sort of a relationship that happens. Okay, so I hope.
So are you allowed to use the RioSoft and then let's say it comes up to 200?
Yes.
And then you say let me go for 210.
Yeah, because that's the minimum. So if you want to more, you're always more than welcome to do that. But that is the minimum that you should have.
You could
In other words, does it mean that of the sample size, based on the probability sample, everybody of the sample size must be addressed? If my sample size is 200,
Yeah.
so does it mean that on probability sampling, the 200 must be addressed?
Yes.
If it's a question of interviews, all the 200 must be interviewed.
Yes. That's what it means. Definitely, if 200, it means the population would be somewhere maybe 15,000, 20,000.
Yes.
But you have to. But the minimum sample required is 200.
But just to follow up on that, you may select your 200 only to find that one of your respondents for some other reasons doesn't respond, or you have to explain those reasons. To say
Yes.
now I have chosen to do 200, however, due to unforeseen circumstances, there is this number that I eventually analyze, so that it actually reduces your level of confidence on the statistic.
Thanks for us raising that, because that's an important area what he is talking about, that sample 200, you go and give your questionnaire to 200 people, maybe 20 won't reply, or they only fill half the questionnaire, so you have to reject that. So ultimately it will come down to 180 only. So it's always a good idea, if there's a 200, you should try to administer 220, so that ultimately it comes down to 200. So
One question, how does it relate to research limitations?
to research.
Limitations.
Okay. See, when you talk about limitation, it's more about the availability of the time or the resources. Basically, limitation is more about the resources.
Not about your subjects.
No, that is called a delimitation. Limitation about the subject is the delimitation or the boundary that you set for your research. That is called a delimit. You delimit your research, say for example, to a particular geographical area only. Because of the limitation of the time, you delimit your study to a particular area only.
If my research is based on an organization and already the population is little, is it necessary to do something because it's just going to bring it down a bit further than
See, normally why we do sampling is because the census is not possible. You cannot go and talk to everybody. That's why we do sampling. And if you are able to talk to everybody in the population, then there's no need of hypothesis also, because everybody says it's in front of you. So you don't have to infer anything. The conclusion is in front of you. Talk to everybody, whatever they say is there. So then it doesn't really. So you do need a sample, because if the sample size is smaller, normally what happens is many times people use a qualitative study. When there is a population is only 50. Normally people go and do a qualitative study, they talk to people at depth, and they do a qualitative study rather than a quantitative in there most of the times. But you do need a sample, because if you are able to talk to everybody in the population, then the statistical methods and everything is of no use, because you don't have to infer. Whatever everybody says, your decision can be based upon that. Then it becomes very easy. Did I answer your question? So it's more, maybe you can do more of a qualitative study than a quantitative in that case. Okay. So now questionnaire design. Now you have thought about You know your population, you know your sample size. Now you have to design your questionnaire and go to the respondents, maybe questionnaire or interview, whatever you are thinking of, you want to design it. There are basically only two ways. One is you design your own questionnaire or a interview questions, or you adapt it from somewhere. See, I would say rather it's better to adapt a questionnaire rather than develop your own. You know, why to invent a wheel when it is already invented? You know, don't try to reinvent. It's already there. Just use it. So you can adapt somebody's. Why do you do that? Is if you create your own, then there are issues of validity and reliability. Because you need to think then whether it's my questionnaire and the question that I'm asking, are they valid? Are they reliable? The data which will I collect out of these, will they be reliable or not? So all that question comes in. So it's a great idea to adapt your questionnaire from some other study, if it is possible. Now the thing is, if it is possible. If it's not possible, definitely you need to go and design your own questionnaire. Right.
That's where I was going.
Yeah. So it's not always possible that you will find something. If it's not, then you have to.
I just want to clarify what you're saying, though.
Yeah.
So you're saying find a similar piece of research that was done close to your topic and utilize their research.
Yes. Yes. You can adapt. Like it won't be exactly the same. Yeah.
Testing independent variables.
Yeah.
It's fine.
And I tell you, sometimes it's a great idea if you can find a similar study. You can also find the statistical methods used by them. You can also follow. No, if something is available, using that information is of. It means that you are smart. You're not a dumb fellow. Somebody already done. Now you are trying to find out what should I do. See, somebody has already done that, and somebody has done it, and that research has been published in a good journal. Now it should not be all those predatory journals and somewhere where you can publish your article. What they say, okay, give us $500 and we'll publish your article. It's simple. There are many, but you should not believe in those kind of journals. It should be a good publisher like Emerald or all those good journals that you have elsewhere and Science Direct or something like a good reputed journal, a Harvard Business Review.
But then the majority of those, they don't attach them.
Yes, very true. They don't attach their questionnaires.
Finding one.
Yes, very true.
Very low.
In some of the articles I read where they talk about their questions, it's very rare though that you will find a questionnaire attached in a research article. Yeah, very rightly said. Okay, so in that case you need to develop your own questionnaire, right? So, yeah.
Is it advisable? Okay,
I'm just asking out of ignorance here. If we're going to, with inverted commas, adapt it,
Yeah.
won't it affect your plagiarism or your missing your originality?
No.
Your percentage?
No.
You reference, you mentioned that you adapted it.
Yeah, because just like a reference that we make, you say that you have adapted it from there.
Or just state?
Yeah, you just state that you have adapted from this particular study.
Yeah. Look, in terms of questionnaire interviews, is it advisable for the researcher to complete or the subject to complete the interview questionnaire?
Okay. I think a very good question. I think so it depends. Even if though ideally speaking, people in today's time, most of the people use again they use SurveyMonkey or something to send the questionnaires also. People are using SurveyMonkey as an online tool that you can use. It's an online tool where you can create your questionnaire and send it to people online. They fill it and send you back. But again, it's a big limitation because the people you are sending it to should have an access to the internet. They should be internet savvy and computer savvy and all those questions. But even if you are manually doing it, going to people and talking to people, yeah, you can also fill because they are. Sometimes some people are averse to doing it. They don't want to take or write or something. You can also do it. This is depending upon. Ideally, the first thing should be if they do it is great. If they don't do it, maybe you can say, okay, this is the question, what they answered, then you take it. This is no problem as far as I think depends upon your respondents. Sometimes they may not understand you. the language that you've written. Sometimes, when you go and administer it personally, you explain it to them.
But especially with interviews, I need to do the notes.
Yeah, see, for interviews, which is a part of a qualitative research, the very interesting thing is, the best idea would be that, you take your notes and everything, but at the same time, it's a good idea always to record it. Because, when you're trying to create a transcript out of that, you cannot really recall what the person said. That's why, and all interviews cannot be structured also. Sometimes, it is unstructured. You may ask certain questions what you have not planned for. Because you feel based upon the answer given in the interview, you say that, okay, based upon that you ask another question.
Follow-up questions.
Follow-up questions, yeah. So it can be unstructured. You should be prepared for unstructured also. That can come up. Okay. So I think we've discussed two kinds of sampling here. Again, remember the criteria. We talked about if you have sampling frame, you can use a probability sampling. If you don't have a sampling frame, you use a non-probability sampling. Now, there are different kinds of probability sampling: random, systematic, cluster, stratified. These are the different kinds of probability sampling. And there are similarly different kinds of non-probability sampling, like a convenience sample or a judgment sampling or a snowball sampling. In a snowball sampling, what happens? Sometimes you do not know where to find the respondents. You find the first one of them and then you ask, where can I find a similar person like you? They suggest you another person and you go to second person. The second person gives you an idea about the third person. So this is how the snowball sampling works sometimes. If you do not have an idea where to find the respondent from. So, in your dissertation, please try and mention that whether you are using a probability or a non-probability and which type of probability and non-probability. And if you can give a reason why are you doing it, it will be great. You can say convenience sampling. Why? Because the first thing you can say, if you have a sampling frame, you cannot say that you are using a convenience sampling now. That's not a very good idea. You have the sampling frame, even then you say it is a convenience based? No, it cannot be. You have to do some of the probability ones only, because you have the sampling frame, then why are you using convenience sampling? It doesn't make sense, it doesn't make logic. Do you agree?
Yes.
You have the list and you should use one of the probability samplings. Provided you don't have a list of population or the sampling frame, then only go on to the non-probability sampling. So which can be a convenience or a judgment or a snowball sampling. Ideally, most of the people use a convenience sampling or maybe a judgment sampling. Sometimes not just convenience but judgment also. Sometimes, say for example, you are talking about a relationship between changing your mobile handsets and maybe the youth. So depending upon, when you see somebody, you feel no, this person may be using a mobile a lot, let me include him in my sample. Sometimes you make a judgment also, who should come in my sample and who should not come. Though it is biased, but still you say, because you have said it's a judgment sampling, there will be bias, but still, because you don't have a sampling frame, you can say that you are using a judgment sampling based upon your judgment also, who should be part of your sample. So please mention this as a part of your, in this particular section, that what sort of method are you using, and please give a justification for that. Most of the times I have seen people are confused. Why are they using probability or why are they using non-probability? Please mention you have the sampling frame or you don't have a sampling frame, that is why you are using a convenience sampling. Now that gives a justification. It cannot be because it was very easy for you, that's why you did it. No. You give a logic that there was no sampling frame, that's why I used a convenience sampling. Give a solid reason for that. Yeah.
So my conclusion then is from what you say, Doctor, that research at the end of the conclusion doesn't necessarily give you an unbiased view. You can deliberately undertake a research project to demonstrate a biased view. Right. It's like 2 weeks ago, let me give you an example. There was research that said husbands stress their wives out more than their children. So clearly that's a judgmental sample. Clearly that's a bias sample.
Yeah, it can happen. I tell you, it can happen. That's why when you do in a business research, try and say as far as possible, try and reduce the bias. It's better to have maybe a convenient sampling rather than a judgmental sampling. Where you say, no, I don't like this face of this person. He doesn't look smart. And let me exclude. That's not. It's better to have a convenience, or you choose a particular area. Find there are a lot of people coming here. I'll include those people. I'll go to a mall and find my population, or I go to or my neighbors, or this and that. There will always be not just bias. There will be some sampling error also. I tell you, sampling or error also occurs. Why? Do you feel all the respondents will give you the correct answer? I tell you, no. When people come to me, I also don't give. So how can I expect others to give? You sometimes, you hide certain details. Okay? So we are not talking about the demographics. Nobody will, because you go to a man, he won't tell you about his real income. Many people say, why would I say? He may report me to SARS or something. So, then what am I earning? So, or maybe you ask a woman her age. She may not tell you the truth. Or all may fall between 20 and 30 only. So, so that's a different thing now. That's a different thing. But even for other questions also, opinion also. Sometimes, there is an error. Why? Because the respondents want to please the interview. You are going and you are asking somebody, the respondent may feel, no, he won't feel it nice. That's why you give nice answers. All good. So, there is always a sampling error, sampling bias. So, again, as you tell, research at the how much can you believe in research? Because I was reading a Harvard article recently. Now this should not go to the contrary of what we are doing, but an article they were saying that still after all this research and everything, your experience and your gut feel, is more prevalent in decision making than this real research. Even after all this research, you somewhere you still feel that no, there's something wrong with this. I cannot base my decision only on this. People still, become judgmental and subjective, and they feel out of their experience, their decision making would be better than that one. Again, so why? Because that's not 100% truth. What the research, it can be biased, errors, and all those kind of things are there. And there are certain variables which you do not even know. Because see, in our entire model, we are saying that there is a relationship between variables. There may be some variables which you have not identified, and there may be a relationship. But you have never identified that, you never thought of that. That may be affecting that.
There is one thing that I read is, for example, if you study respondents low-level employees within an authoritarian kind of organization, they usually prefer to respond in a manner that pleases their bosses, even if they are not, the boss is not there.
Yes.
So that those kind of things need to be considered, especially when you're drawing your conclusions.
Yes, I think very true. That's why, whenever you develop a questionnaire or something, never ask the contact details, the name, the phone number, the email ID, the address. It should never be asked in a questionnaire or an interview. No, because we are not concerned whether the name is X or Y. It doesn't affect our research. The name would never affect. Maybe the age or the gender may affect, but no, the name won't affect. What is the name, or what is the phone number, or what is the email ID? It doesn't affect our research. So that's why you should never be asked. So let the respondent feel free that they can respond freely. Okay. Another important area is the validity and reliability. Now, because we talked about our questionnaire, now validity, there are two things. First thing is the reliability. See, reliability, remember reliability with repeatability. If you are going to repeat, or if you are again going to collect another sample, will it result into the same outcome or not? Can you draw the same conclusion again if you draw another sample? That is basically what is reliability. That's where you call it is reliable. I have done this research, somebody else also does this research. He will also find the same thing. It means it's reliable, right? So reliability refers to the repeatability of findings. If the study were to be done a second time, would it yield the same results? If so, the data are reliable. That's what you call reliability. So remember, reliability, repeatability. You can remember it easily. Reliability equals repeatability. Can it be repeated? If yes, okay, it's reliable. And to find or to check reliability, you can use Cronbach alpha. That's a statistical tool that you can use. A score of over 0.60 is considered to be reliable. If your Cronbach alpha score is, because it will lie between 0 and 1, anything above 0.6 equal to or more than 0.6 is considered reliable. Now you don't have to worry again because there is a calculator available online again. So no need to worry. Just put your data there. That will give you whether it's reliable or not. So click on to this. It will take you to this educational research basics by Regenesys, and here you will find, see here there is Excel spreadsheet, XLS, it's written here, you will find here, and when you click here, you can download their calculator and it looks something like this. So you have all your respondents here, subject or respondent 1, 2, 3, 4, whatever, your different questions, and whatever your result is, you have to just, or input your data here. It will give you, the Cronbach alpha. Here it is. It will give you a score. It's that simple. Just put in your, like for example, let us try and put something here. So respondent 1, 3. I input this data, it gives me a Cronbach alpha of 0.33. It means it's not reliable. Similarly, you have to just input your data in this Excel spreadsheet. It will give you a score. So this is very simple. So normally, when you collect all your data, definitely you have to convert all your data into an Excel spreadsheet. An Excel spreadsheet should also look like this only. You have all your respondents here. Say for example, you have 50 respondents. Mention all your respondents, all your questions here. You will put your values, whatever you gathered through your questionnaire. Input that will be an Excel spreadsheet. So you can just copy paste it here. It will give you a Cronbach alpha score.
It's not only applicable to quantitative methods.
Yes. Yeah.
And then when we're done, we attach this as an annex check.
Yes. You can always refer that you have used this online thing.
Is it only working online?
No, it is downloadable. This will be done. This is downloaded and then you can.
Send it as part of the package.
I will send you the link because again, it will be a link because this is not the propriety. It's not Regenesys propriety. It is available as a link online. So I'll send you the link. You can download it yourself and then you can use it. So it's easy, like,
Just add one more question. The Riosoft software, is it only applicable one for deductive approach?
see why, okay.
Can you use it for qualitative research?
Normally it is not used. Why, I'll tell you. Because see, what happens is normally in a qualitative one, the way you approach is very different. Because you are not, there is no hypothesis in a qualitative. You are not testing hypothesis. It means you are not using any statistical tool. Because you are not using statistical tool, you do not have to really go through this validity and reliability test. So there's another, and the sample size and everything is different. Say for example, you're doing a case study method, or you're doing an observation. So observation can be only one or two places. You observe something at two different settings, you know, an office setup or only a case study of only one company. So now this is not really usable there. It's more of quantitative that we use. Okay, so that was more about the reliability. Now validity. Now reliability have a test, but somehow validity has got no test. There is no validity test available. You only need to understand and describe it in your research. What does it mean? See, validity basically means the credibility or the believability of the research. It refers to how well the results of a study measure what they are intended to measure. Remember we talked about like poor performance. How do we measure poor performance? So the questions that we have asked, are they really measuring poor performance, or are they really measuring the consumer behavior? You know. So that's why, you know, your question, after a questionnaire, your data should talk about this. Is this really valid? Can you really believe? Are you trying to, have you really measured what you were trying to measure through your questionnaire? You know, you develop all that model and everything is fine, but unless you are able to measure what you are trying to measure, you know, it will not become valid. So there are two kinds of validity. One is called an internal validity, and another is called an external validity. Internal validity is the instruments or procedure used in the research measured what they were supposed to measure. So say, okay, a questionnaire or an interview measured what they intended to measure. That's the internal one. The external validity, the results can be generalized beyond the immediate study. In order to have external validity, the claim that whatever, studying in several sessions is better than, okay, so it should also apply to people beyond the sample. It means you can generalize this study otherwise also. So that talks about the external validity. Okay, now, yeah.
Yeah, but from that, does it not mean that you can only generalize it to the extent to which it applies, which is with your general population?
See, that's what it's saying. If it is only internally valid, it means it only applies to that particular research.
Yeah.
But if it is an externally valid also, it means it can be generalized. Now,
By the population.
yeah, to other populations also. So you can generalize it. And so, you know, when you are trying to make your conclusions and recommendations, remember this. Can you really generalize it? You know, so that's where it comes from. Okay. Now, but don't get confused. Most of the times we are more concerned with the internal validity. As far as concerned, we are more concerned about the internal validity, because external validity is really difficult, I tell you. So let's talk about internal validity only, and what are the different kinds of validity. There are three kinds basically: criteria validity, content validity, and the construct validity. Now briefly I will go through what does it mean. Once you know what it means, then you can really explain it in your dissertation. So first of all is the content. It really says the content. It means the questions that are there in the questionnaire, you know, should be such. You should ask a question, say for example, poor performance. So how to measure poor performance? So there must be certain questions that we can ask to measure poor performance. So the questions that you have asked should come from the pool of the entire questions that you can ask. Say for example, there are possible 100 questions, that can be asked to measure poor performance. So your question should come out of those 100 questions only. Then it means it is content-wise valid. So the idea behind content validity is that questions administered in a survey, a questionnaire or a focus group come from a larger pool of relevant content. For example, if you are measuring the vocabulary of third graders, your evaluation includes a subset of the words third graders need to learn. It means that's when your content is considered to be valid. That's where your questions are considered valid. But the problem is there is no direct measure of content validity. To establish content validity, you consult experts in the field and look for a consensus of judgment. So that's what you can do. You cannot have a test, but you can go and ask the experts or people with experience that, okay, I have these questions. Now, do you feel these questions are relevant? These questions measure poor performance, or this measures the consumer behavior, You need to go and talk to the experts. So in your research, you can mention that you have talk to the experts, or you can mention a bit of paragraph on that and say, and that is why your content is valid. That's how you logically you explain that why do you think your questions are correct? Why do you feel your contents are valid? That you have consulted the experts in that field, people who are experienced with knowledge. Measuring content validity therefore entails a certain amount of subjectivity. That is a bit of subjectivity, albeit with consensus. So you go and talk to 4 or 5 people, experts, and then you come to a consensus, okay, now your questionnaire is fine, the questions that you have asked are fine. That it means your content is valid. Isn't it logical? Like you go and ask the experts, what do you do otherwise? The second kind of validity is the criteria related validity. Okay. Usually customer research is conducted to predict an outcome, which may be a better user experience, happier customers, higher conversion rate, more customer recommending, more sales. We can think of these outcomes as criteria. We want our measures to properly predict this criteria. So what happens in a criteria? Like the same goes, poor performance. Now what is the criteria of poor performance? Okay. So you say, okay, these are the different criteria. Now how do you find that this is a valid criteria? There has to be some sort of a correlation, isn't it? Like policy and poor performance. So you can statistically go and try to find a correlation between these two. That's what we call to assess criteria related validity. We correlate our measure with a criteria using the correlation coefficient R. So you can go statistically and test it. Because you talked about that policy and poor performance, because you say that policy is a criteria of poor performance, one of the criteria. Then you say, is there a correlation? Go and check the correlation. If there is a good correlation, one is perfect, considered to be a perfect correlation. Is that a good correlation or not? You can do that. I'll come what you are expected to do, right? Because this is what you can do. But minimum what you can do. There's 2 things. This is what you can do. So you can talk about content validity, you can talk about criteria validity, and then there is a third kind of validity also. Okay, let's talk about criteria validity only further. So criteria validity measures how well one measures predicts an outcome for another measure. A test has this type of validity if it is useful for predicting performance or behavior in another situation. For example, a job applicant takes a performance test during the interview process. If this test accurately predicts how well the employee will perform on the job, the test is said to have criteria validity, isn't it? The test is a good criteria. So similarly, whatever you are using criteria, is there a relationship or not? A graduate student taking the GRE, the GRE has been shown as an efficient tool for predicting how well a student will perform in graduate studies. So in all these criteria that we use. So how we can find out? Let's find out a correlation between these two. Now in your dissertation, if you find it too much to do all this, you should at least do the content validity. Are you getting me? Though it will be great if you use content, criteria and construct all the three validities. If you cannot, because criteria related validity talks about, again, you have to use a correlation, do that. If you do that, it's very, very good. Okay. Now third kind of validity talks about a construct validity. But the construct validity is not applicable to all the research. Depending upon the kind of research, you may be required to do a construct validity. So you need to understand what is construct. When you are talking about a construct in relation to testing and construct validity, it has nothing to do with the way a test is designed or constructed. Please remember, it doesn't mean how have you designed or constructed your questionnaire. No, it is not about that. A construct is something that happens in the brain, like a skill level of emotion, ability or proficiency. Something which happens in your mind, which you cannot really measure. How can you measure, level of emotion? Emotionally he is weak. What is the measure? How do we measure it? It's very difficult. Or like similarly proficiency. You can say that he is very proficient, but how do you do that? This construct which happens in the mind. For example, like maybe proficiency in a language. Somebody says, okay, he is very proficient in French or German or English or any other language. How do you really find it out? It's difficult. So construct validity is one way to test the validity of a test. It's used in education, the social sciences and psychology. It's not used in all kinds of research. It demonstrates that the test is actually measuring the construct it claims it's measuring. For example, you may try to find out if an educational program increases emotional maturity in elementary school age children. Construct validity would measure if your research is actually measuring emotional maturity or not. Okay. Now, how to measure? The important part is, now how do you measure this construct validity? Again, there is no test. So what you do is, you include pilot studies and clinical trials. Clinical trial is not part of the business research, right? We do not do clinical trials. So what you can do is pilot study, right? So if your research requires any of these constructs, you can, you should include as part. In fact, you should always try and include a part in your dissertation that a pilot study was done. It's always a good idea to do a pilot study. Take your questionnaire to 5-10 people. Ask them to fill the questionnaire. First of all, do they understand the questions? You feel that you have a wonderful questionnaire. When you go to the respondents are not able to understand what are you trying to ask. They say, what is this? I don't even understand this. It means you need to go and change. There is some problem in the way you have designed your questionnaire. That's why you can use, always it's a good idea to run a pilot study. Run on 5-10 people.
But you run your pilot study to your target, with your target.
Yeah, with the target population. Yes, you run that within your target population. To understand whether it's whether they are able to understand what you are trying to ask. One of the reasons it's so hard to measure is one of the reasons it exists. In the social sciences, there is a lot of subjectivity and most constructs have no real unit of measurement. Even those constructs that do have an acceptable measurement scale like IQ are open to debate. So now we see there are three kinds of,
Can I ask one question? If you're going to run the pilot on the population, and then you still haven't chosen the actual respondents in that, what effect will it have what effect will it have that you now administer possibly to the same person that was involved in the pilot?
Okay, see, again, you are asking some wonderful questions today. Good.
So,
No, you are asking some very good questions today. very valid. Okay, I do understand, see what happens is, if you are trying to modify a questionnaire after a pilot study, please don't go to the same respondents again. Because they would understand now that, that you are not a great researcher or something. That's why, because you have only done a pilot study of 4 or 5 people. Even if you exclude them, it won't be a big problem. It won't be a big problem. Even if you, or maybe if you really know them well and you are able to explain to them that, okay, the last time when you were trying to answer this question, you were very confused. Now see, what about this question? Do you really understand this question now? So it depends upon the kind of respondents that you have, So if at all you feel that it will have a negative effect, why to go to the same respondents again? Like, okay. So now reliability and validity. See, reliability was very easy. You go through Cronbach alpha, you go through that calculator, download it, put your data, it will give you a result. If your Cronbach alpha is more than 0.60, it means it is reliable. Then come to the validity part. First thing is content validity. So it's not difficult. Go to the experts. It requires a bit of effort. It requires efforts that you find the experts in that area, talk to them, and then finalize your questionnaire. So you can always do that. But the only thing is, do you know the experts? Are you able to find them? It will take some time. But it's always good, and then you can, sometimes there are some researchers who are over smart. They never contact, these experts, but they just write a line. I have contacted the expert and they say, no, these questions are fine. Now it depends how ethical you are. Like, nobody can prove you wrong, but whether you're contacted or not, nobody would know that. But it's good for your own research, because when you go to an expert, he may say, no, this is a useless question. Or maybe he may suggest you to ask, to add 2 more questions to that, which are very, very important. So now it depends, nobody can really find out whether you have gone to the experts or not. But you can always mention that, and so that, why do you think your data is valid? You say this content-wise is valid because I have contacted the experts in that area. Okay. Criteria related.
Do you reference your situations?
Okay. That can be wonderful. Yes. That can be great if you can say that you contacted this people. Yeah, that can be a great idea. That will only happen if you have really contacted. Yeah. I think that's a good idea. I think that's a good idea. We can, among our supervisors, we can discuss that. Let's ask all our researchers to include the name as well. Or maybe, a sort of a appendix, a statement that, okay, these experts were contacted and there's something, I don't know. Okay. And then second is the criteria related validity. If you really want to prove it, again, you need to run a correlation. This correlation is a wonderful. Okay.
Still on the question of experts, there is a wide range of experts.
Yes.
And I've realized when you allocate the supervisors, usually struggling with getting experts in those fields. So how easy is it for me as a researcher, a student, to identify those experts?
See, because you only need to find out those experts. Supervisor may or may not be able to guide you in that. He may be one of those experts. He may be. I don't say he can be, but he may be one of those. But it will be. You need to really go and identify those experts in that area. Yeah. Okay. So if it's a criteria related validity, okay, you say you have talked about a particular criteria, you find out a correlation, run a correlation study. Correlation only talks about that these 2 things are related. It never talks about that, there is a cause and effect relationship. Don't get confused ever about that correlation can talk about cause and effect relation. It only talks about two variables are related to each other. How are they related? The correlation won't tell you. For that, there is another statistical tool. So you can just run a correlation to talk about that there is relationship between these two variables. That is why I have used it in my questionnaire. That's another. If it is possible for you, you can run a criteria related validity also. Now, it becomes difficult because there will be so many correlations that you have to find out now. Because all those, if you are using 5 criteria to measure one question and you have 5 questions, it means you have to find out 25 correlations now. So, if it is possible, it's fine. If it's not possible, okay, you can talk about your content validity. And then, if a construct validity is applicable, talk about a construct validity. Even if your construct validity is not applicable, you can always talk about a pilot study. It's always a great idea to run a pilot study. You can always talk that you have run. In all my research papers, whenever I do, I always run a pilot study. And that has always been useful. Why? Because I develop a questionnaire based upon my thought process. When I go to the respondent, I find they are not able to understand what I am trying to ask. Then I have to modify my question and again go back. It has always worked for me. I tell you, it's always a great idea to have a pilot study. Okay, so I hope now this is clear. Reliability and validity. Two things very important. Sometimes people just ask, no, my data is reliable. How did you find out? The only way to find out reliability is run a Kronberg alpha or maybe if you can find another reliability test. But Kronberg alpha is simple because there is a calculator also available. You ask. Okay. So you mentioned this. Okay. We really have a short time because this chapter because somehow I also love research and I also get attached when I am facilitating. So and I want to discuss more and bring out my experience and share my experience also. That's why I did all this modeling thing based upon my experience only. Though when you talk about this model, when it is used, there is a statistical tool which is called a structural equation modeling. That's where normally we use this model. But even I found out through my experience that even if you are not using it, it is a wonderful tool to understand your research. So I brought it from there, structural equation modeling. We are not doing it because it's a very high level of, it really takes a lot of time to understand that and you need to have that software. And or maybe you go to a statistician and find a software and understand how it really works or something. So, but it comes from there. Okay. Now we come to the next part, and that is we've done all this now. We try to understand all this is that people when you think about analysis, you think okay, you have the data, put a test, and that's analyzed final. No, all what we did so far is very important. If you don't know that, you cannot come on and do the data analysis. Okay. Now, first of all, I'm trying to talk about quantitative data. So, to understand what statistical tools can you use, you need to understand these two things. The type of distribution of the curve that you have and the type of data that you have. Now, these two things are necessary. If you understand these two things, you will be able to understand what kind of test is required. Then it becomes simple. Again, it's a concept. Try and understand as a concept. Then you will be able to apply the correct statistical tool. Remember the conceptually what it is. Right? So if your data fits a normal distribution, approximately 60% of your subjects will fall within one standard deviation of the mean. What it's trying to say here is that if it is a normal distribution, and you find out a mean, so approximately 60% of your respondents or the subject will fall within one standard deviation, and you also calculate the standard deviation. Say for example, your mean is 20 and your standard deviation is 2. 2 can be on either side, left and right. It means if your average is 20 and standard deviation is 2, it means it can be, so the range will lie between 18 and 22 now. Are you getting me? See, for example, if mean is 20, standard deviation is 2, so range will happen between 18 and 22, isn't it? It's that simple. Okay. Approximately 60% of a subject will fall within one standard deviation. So if you know it's a normal distribution, you calculate your mean, you calculate a standard deviation, you can say 60% of the entire respondents, what will be their value. That's the purpose. Now again, this is just descriptive statistics. You are just describing the data that you have collected. You cannot infer anything. You cannot say that there is a relationship between variables based upon your descriptive statistics. It only describes your data, nothing else. Right? That's why now I'm not going into the detail of all this. Just you should understand the conceptually that you need to understand. The biggest thing is to be understood is the data that you have collected falls into a normal distribution or not. Right? Okay. See the same, just an example, on one mathematics test, standard deviation may be 7 points. If the mean were 45, then we would know that 80% of the students' score are from 38 to 52. That's the range of the marks of the students. So this is just the utility of the standard deviation. Now, we have said that normal distribution, but all the data all the times are not normally distributed. Sometimes your curve will be skewed, skewness will happen. Data do not always form a normal distribution. When most of the scores are high, the distribution is not normal but negatively skewed. See, most of the data are high, this is negative. So this is negatively skewed. How to find out whether it's negatively skewed or positively skewed? Wherever there is a skew means the tail. So wherever there is a tail, it means it is negative. It is going towards negative. It means negatively skewed. Skew refers to the tail of the distribution. Okay. Because the tail is on the negative side of the graph, the distribution has a negative skew. Okay. Similarly, it can be right skewed also. So because the tail is on the positive side of the graph, the distribution has a positive skew. Okay. So when data are skewed, they do not possess the characteristics of the normal distribution. So now, the moment the data is skewed, you cannot say that mean is equal to mode is equal to median. That thing goes off. It only happens in a normal distribution. So, the mean, mode and median do not fall on the same score. The mode will still be represented by the highest point of the distribution, but the mean will be towards the side with the tail, and median will fall between the mode and mean. So this is just, so don't get confused. Remember one point, whether your data is normally distributed or not. That's really, really important. Based upon that, we'll see how does it affect the statistical test that you are going to use. So how do you find that the data is normally distributed? You can look at the bar graph, or you can find is mean is equal to mode is equal to median, or skewness is between -2 and +2, kurtosis between -2 and +2. So, but the easiest way is to find out is mean is equal to mode is equal to median. Just find it out. If it is yes, it's a normal distribution. Okay. Okay, I'm not going through the video because I think again time has its own limitation. So I think we have already talked about standard deviation. It's nothing but it's measured the amount of scatter in the units of the data. You know, it's how much your data differs from the mean. That is a standard deviation. I think when you go through these slides, you can run these videos and watch for yourself, because initially I planned to use them, but I think it's already 12, so okay. Skewness we have talked about. Then another concept called kurtosis. Kurtosis is nothing but which is talking about the peakedness of the, you know, your distribution. How peak is your distribution? See, it's like peak. Sometimes it's like the peak is very high. Sometimes it is flat. You know, so kurtosis is nothing but talks about how peaked is your distribution. Nothing else. So don't get worried about that. Again, it's a very long thing. I'm not going through the details here. Okay. Now, so we initially talked about two criteria to go about quantitative data analysis. The first is your data normally distributed or not? We have discussed the first point. Now the second point is, what kind of data do you have? Is it nominal, ordinal, interview, or ratio? The data that you collect may fall under one of these categories depending upon the kind of questionnaire that you have. So we need to understand what does it really mean. Nominal, it talks about name, you know, nominal or categorical, like a question that, you know, are you a male or a female? It's a nominal data or a categorical data, isn't it? Similarly, there can be an ordinal data, like a rank or a sequence. I hope you know the Likert scales, you know. Do you agree? Some people say highly, you know, you strongly agree, disagree, all those, there is a basically rank. Those are called as an ordinal data. Then you have got interval and the ratio data where you have certain numbers like height, weight, you know, there is a numerical number, you know, you can say, you can measure them. Height or weight or maybe the sales or your market share or the rainfall or the productivity, no, not productivity, production. You can measure it, you know, there are certain numbers. Those comes under interval or a ratio data. So remember, there's three things. Nominal data talks about the name or the category, like which color do you prefer? Black, yellow, red, white. These are basically categories. Or are you a male or a female? You know? Okay. So based upon the data that you have, so there are two criteria, distribution and the type of the data that you have. I'm not going into the details of different data types. We have already discussed. Nominal, like say for example, you say in which municipality do you live? Johannesburg, Pretoria, Germiston, or whatever you say. That's more of a categorical. Why it is called a categorical? Because normally when you ask, you give a number. There's Johannesburg 1, Pretoria 2, Germiston 3. But even if you give Pretoria 1 and Johannesburg 2, it won't really matter. You know, the order of this doesn't matter, isn't it? You can interchange this. So it doesn't matter. That's why it's nominal. Or you just give a name to it. Then you have ordinal data, like what is your overall reaction to the eToll system? You say very satisfied, satisfied, neutral, dissatisfied, very dissatisfied. You know, there is a rank or an order. You know, that becomes an ordinal data now. And now you can ask, you know, your overall reaction to the increase in the VAT. Another question. Okay, so then you can have so these are two kinds of data, and then you can have an interval data or a ratio data. To be easily remembered, remember that it talks in terms of the numerical value. Something which can has a numerical value will be an interval data or a ratio data. You know, so it's easy way to remember is that. Don't get confused. Okay, I hope you understand now the nominal, ordinal and interval ratio data, right? Okay. Now, I don't want, there are so many things in research, so okay. I think you can go through, some of these are self-explanatory also, that's why I'm not, it only talks about what do you mean by confidence level. It's basically confidence level and the confidence interval. So you can read it. Okay. So I think now descriptive statistics in brief. We have discussed it again briefly. I am discussing it. Mean is the average of all values. But remember, it gets affected by the extreme values. Now what does it mean it gets affected by extreme values? Say for example, you are thinking of the average salary of 20 employees. Suddenly you find one of them is the CEO. And everybody else, the salary is ranging between maybe 300,000 to 500,000. And suddenly you have a CEO who earns 10 million. So suddenly that will increase the average, isn't it? So average gets influenced by these extreme values. That's the problem with the average, isn't it? Suddenly your average will look like wonderful. We don't know it's because of that one person. You remove that and the average will come down. That doesn't really represent the entire population, that average, isn't it? That's the problem with the mean. Then mode is the value with the highest frequency that we have seen. Something which repeats the most often. Median is the middle value and does not get affected by the extreme values. It is always will be in the middle. That's the middle value. Standard deviation, it is mostly used in financial risk analysis. This indicates the spread of the value from the mean. How far does the value is there from the mean? So how many units away from the mean? Correlation shows pairs of variables, how pairs of variables are related, how two variables are related to each other. That is shown through correlation. Skewness is again a measure of spread of data. We have seen it can be negatively skewed or positively skewed. And kurtosis, it's a measure of peakedness of the data. This is in general, what some very true researchers do is before they do or apply any inferential statistics or before they test their hypothesis, they run a descriptive statistics. They describe their data. Now it's not necessary to describe all of them, but you can definitely talk about mean, mode, median, standard deviation. These 3-4 things at least you can talk about. You can talk about your data, describe the data that you have collected. Okay. I'm not going into this again because shortage of time. I hope how do you prepare your data in an Excel sheet? I hope you already know. We ran one of the videos where you have, your respondents and all the questions, they input your data in an Excel sheet. Now everything else is done by software, you don't have to do. That's why for me, it's more important to understand the concept and the test that you should apply, rather than the test itself. People get so much involved in the test. The test is done by the software. What are you doing in that? You should know which test is applicable. Conceptually, I think that's very, very important to understand the test that you should apply, rather than the test itself. Test is important, but you should understand which test is to be applied first. And then it's just about your data. You have to just input your data in the software. Everything else is done by the software. You do nothing. You only select which test is to be done. Okay. Now here are some criteria. This is important. Type of variable and the best measure of central tendency. That what should you use when? If the type of the data or the variable is nominal, you should talk about the mode. If it is ordinal, best measure of central tendency is the median. If it is the interval or the ratio data which is not skewed, mean is the best method. If your interval ratio data is skewed, median is the best method. These are some of the criteria you can use while trying to describe your data. So that's really important, which you should understand what to use when. So this is, you can use as a criteria. Mean, mode, median, what is to be used when. That's why I told you you need to understand the type of the data that you have. So it's nominal, ordinal, interval, ratio. You can easily use it. Okay. Okay. Now, inferential statistics, which is really used to test your hypothesis. To infer something, you need to test your hypothesis that you developed earlier, because you have to prove or disprove your null hypothesis now. So there are many tests. I'm only trying to talk about a few of them, which I feel are really important, and you can cover up most of this test. T-test, Z-test, chi-square, ANOVA, and regression. Don't get confused. I'll talk in very simple terms that you can understand. My purpose is that. So T-test. So when do you use a T-test? A T-test is used to examine how the means taken from two independent samples differ. Okay. Two independent samples. Now what does it mean? Let's say, for example, in a department, training is given to one set of employees, and it's not given to another set of employees. Then they try to compare the productivity or the efficiency of these people. So you are trying to find out the mean of two different samples. Or maybe training X is given to one set of employees and training Y is given to another set of employees. Then you try to measure which was more efficient. Or you ran two different types of sales promotion. Then you try to say, okay, you apply one to one area, another to another area. Or maybe first 6 months you apply first sales promotion technique, next 6 months you apply another sales promotion technique. Try to compare. Okay? Those kind of situations you use a T-test. Okay? That's what is mean by, is used to examine how the mean taken from two independent samples differ. So what are the conditions to be used? It can be used if the data is interval or ratio and a normal distribution. Now see, that's why those two criteria were important. If it is an interval or a ratio data and a normal distribution, you can use a T-test. So that's the condition of a T-test. Okay. Second, it is used for sample size less than 30. So sample size, if it is less than 30, use a T-test. For larger sample, it is replaced by Z-test. Okay. So if your sample size is more than 30, use a Z-test. If it is up to 30, use a T-test. Okay. Again, T-test can be of two types: independent T-test and the paired T-test. Independent T-test compare two groups independent of each other. Like in our example, training was given to one group and not given to another group. So these are two groups which are independent of each other. Or it can be a paired T-test, compare two groups dependent on each other. It's like you give one sort of a training today and compare the results, and then give another sort of a training another time and compare the results. So group remains the same, the treatment differs. It's like on a patient you give one medicine and say that, okay, how does it work? You give another medicine and say, how does it work? That's basically the paired T-test, those kind of situations. Okay. So ideally you should remember 2-3 things here. One is, it has to be an interval or ratio data and a normal distribution. That's the first thing you need to know. Second is, there are two groups of people, two different samples that you have taken. Like you have applied a medicine, you have applied a treatment, or you have given, you have done something to one group and not done to another. Or at two different times you have done two different sort of trainings or experiments. That's where you apply a T-test. So in a Z-test, as I told, if the sample size is more than 30, instead of a T-test, you can go in and use a Z-test. To test if the means of the two data sets differ from each other. Again, it can be used if the data is interval or ratio and a normal distribution. used for sample size greater than 30. And there is one more condition when population standard deviation is known. But do not get confused, it is more of a theoretical because in exams and universities you have certain statistic examination where you use all these conditions. But in true research, you just look at these two things: ratio and a normal distribution and sample size greater than 30. You can go ahead and use a Z test.
And is there software to conduct this t-test?
Yes, they are available. SPSS, you can do all this test. You just need to input your data and say and select which test do you want to use. Now that's why I am discussing when to use. Because how to do it is very simple. You just take your data from your Excel sheet, put it into the software. It will do everything for you. So you have to do just nothing.
What's the name of the software?
Yeah?
Name of the software?
SPSS. This is one of the most commonly used softwares for business research, social research. Though there are others also, sometimes it's not easy to understand this software. There is another software called PSPP. Because this software SPSS, you have to buy this software. There is a 30-day free trial that you can get, but within the 30 days you will be only to understand that how to use it. PSPP is a user-friendly software. You can just, and it is free. You can just go download it. You can simply export your data from Excel to this software and it will give you the results. This is a much easier software. I haven't used PSPP, but many people have used, and from there what they talk about is it is much easier to use it. It's freely downloadable, so you can download it. Okay. Then the third thing I want to talk about is the chi-square. Chi-square statistic is commonly used for testing relationship between categorical variables. We have talked about interval. Now what about nominal or categorical variables? So chi-square can be used for that. If your data is nominal or categorical, go for a chi-square test. Don't do a t-test or a z-test. Go for instead for a chi-square test. For example, in an election survey, voters might be classified by gender and voting preference, like a Democrat, Republican, Independent. Maybe this example is more from US or something. That's why, what you can say. We could use a chi-square test for independence to determine whether gender is related to voting preference. Relationship of gender to voting preference. So this is a nominal data or a categorical data. That's why we are using a chi-square and not using a t-test or a z-test. Why? Because it's a nominal data. It isn't an interval data. Now you see the difference. That's why you need to understand what kind of data you have. So like condition, the sampling method is simple random sampling. The variables under study are categorical. If sample data are displayed in a contingency table, the expected frequency count for each cell of the table is at least. Okay, that's fine. I think the more important thing is it is a categorical variable, and it's also talk about simple random sampling. It means it should be a probability sampling. So probability sampling, categorical data, use chi-square. So this all sort of combination you need to understand. Okay. Then ANOVA or analysis of variance is another tool. It's quite similar to t-test. There is only one difference. In a t-test, what happens is we are trying to measure between two groups. What happens if there are more than two groups? You collect sample not only from two groups, or maybe from 10 groups or 15 groups of different samples. So where a comparison is to be made between more than two population means, like the yield of the crop from multiple seed varieties. So yield of the crop from multiple seed varieties. So first of all you have first variety, then the second variety, third, fourth, fifth, sixth, seventh. There are many. So it's multiple. In that case you cannot use a t-test. You have to go in for analysis of variance or ANOVA. Again, there are conditions. The sample is drawn from the normally distributed population, and the population variance is known. So what you should remember again, it should come from a normally distributed population. Normal distribution. Again, the condition of normal distribution is there. Okay. Now you may be feeling that what happens is if it's not normal, data is also not interval. On the last test, if this doesn't, this is a wonderful, I think it's the best tool to be used in business research. I prefer this. Why? Because first of all, see when to use to describe the relationship between a set of independent variables and the dependent variables. That's what we try to do, isn't it? This is one of the best ways. In business research, I think one of the most preferred way of doing research is through regression. So, and it doesn't talk about that the data should come from a normal distribution. It doesn't talk about it should form a interval data. So all those restrictions are not there, and you can measure the relationship. That's why this tool becomes a very wonderful tool, isn't it? It's better than all those tools, regression analysis. For the same article, a detailed article, a link is given. And this is an HBR article, wonderful article. You can just go through, you'll better understand what is regression analysis. Most of the times in business research, people are using regression. Please remember, one of the best ways to research is through regression. Because what happens is one dependent variable and there can be 5, 6, 7 independent variables, it can easily find out the relationship. That's the tool that is to be used. So I think in most of our research you can use...
So just as a quick question, Doctor, if you use regression analysis, do you still do the t-test?
No.
Choose one of them.
One of them. You have to only choose one
Okay.
to test your hypothesis. So I think regression is coming out to be one of the best tools. Most of the business research people are using regression, and if you really want to do an advanced thing, then you do a structure equation modeling. But normally in business research, people are using regression to find out the relationship between dependent and independent. That's what normally I think most of our research would fall under. So that's the best tool to be used is regression analysis. Again, there can be simple regression or there can be multiple regression analysis. Simple is used to estimate the relationship between a dependent variable and a single independent variable. For example, the relationship between crop yield and rainfall. So if it's only two variables, one independent and one dependent, you can have a simple regression. Or if there are many variables, you can use a multiple regression analysis. It's used to estimate the relationship between a dependent variable and two or more independent variables. For example, the relationship between the salary of employees and their experience and education, and maybe you can add more. So that's why it's a wonderful tool. You can have n number of 10 independent variables. Okay, fine. You can do a regression analysis. So that's how you really convert. So I think these are the basic tools to really do a quantitative analysis. See, now you need to look back at your research and try to find out which will be the best tool to test the hypothesis. I've given you certain criteria also, but I think for regression, because the criteria is also not much. You're not talking about it should come from a normal distribution and all those criteria goes away. It means it's easy to go ahead with regression analysis. So I think I would suggest if it's possible, go through a regression analysis for your research, quantitative. Okay. I hope the quantitative data analysis is clear. Because it's a limited time, otherwise we would have done more in-depth thing, but limitation of time. I'll still it's time, but we haven't touched the qualitative so far. And I'll briefly touch upon, and then you can let me know that if you really feel that we haven't touched qualitative in detail, we can run another workshop only for qualitative in that case. Because I was hoping that I will be able to cover, but I think we couldn't have done faster than what we have done because there's a lot to discuss. I'll briefly touch upon. Now you can please let me know if it's if you really require, we can have additional one more workshop only for qualitative.
I think we'd rather conclude on this one. We don't have a qualitative one specific.
Okay, so entirely we run one more workshop for qualitative. Yeah, we'll do that. Okay, okay. So just in very short, I'm not discussing in detail, but qualitative, what really happens? You know, you say, for example, you observe something, you take an interview. What do you do then? You record it, you take certain notes, and then what you do is you convert it into sort of a transcript, isn't it? You convert what you have observed or taken interview, convert into transcript. Then after taking your transcript, what you do is you convert your transcript into some sort of a codes. Now code is nothing but something talks about one observation, that, you know, say a poor performance only. You talk about the same topic and go to an expert and say talking. They say no policy, for example. You say okay. They are talking about because of the poor policy this is happening. You say okay. Now policy becomes one of the codes. So whatever you develop certain codes out of the transcript. Then you can say that there is some relationship between 2-3 different codes, and they can all fall under one category. So from a code you can develop a category. That 5-6 codes can come under one category. Similarly, you go through all the transcripts of all the interviews, and finally you arrive at that maybe sometimes in qualitative it can be 200 codes, 250 codes. And from 250 codes you can have 10-12 categories. And then you say, theoretically speaking, can there be some relationship? Now then you try and find out relationship between those different categories. Okay, so it's like from code you go to the category. It's something like so you can have 4, 5, 6 codes all fall under one category. Similarly, another course, another category, you know, all you convert all that. And finally you say, okay, category 1 and 2. Then you try to find out relationship between these categories, the way we did earlier for our quantitative. What sort of relationship is there? And based upon that relationship, what you do is, you say, okay, it means this. So then you develop a theory out of those linkages that you find. Out of the categories that you find, you say, okay, ultimately I can develop a theory out of that. That's what you do. But normally what happens is, you need to apply and reapply before you can really generalize a theory. That's why it's a time-taking process. But that's the normal process that you do. Convert your transcript into code. From the code, develop a category. From different categories, try to link different categories to each other. And from that, try to develop a theory. That's what is the process of a qualitative research. Now it's not easy, I tell you. Again, there are softwares for qualitative research also. There is a software called Hyper Research, which does nothing but, you know, the way you create codes. You know, so what it says that you have to input your transcript into that software. And then, you know, then you can create codes out of that. And then that creates categories. So there's also software, not as advanced as quantitative, but there are softwares. So you don't have to do manually. You just type and put all your transcript into that, and that will create. And then you say, okay, this is. Then you mention your codes. Then you have to. It's like cut, copy, paste. You drag and drop. Okay, this goes under code 1. This goes under code 2. Now this code goes under category 1. Just like that. Ultimately, a sort of a theory will develop. So, I think with the shortage of time, I think we can run another workshop just for the qualitative, so we can discuss in detail